Before opening the floor to questions, I'd like to mention just another aspect of Professor Liu's work. He's our chief undergraduate advisor for mathematics, and working with Professor Eichhorn and Professor Julian Turing, the chair of mathematics. They've been working very hard to improve even more the education of our UCI students. So in addition to doing this beautiful abstract work, Professor Liu really works hard in the real world also. And with that, I just ask if there are any questions. We have one here. Yes.
Is mathematics research a young man's game? Are only young people able to carry the levels of abstraction?
Well, people say that, but I don't think so. I don't agree with that, because I believe the most important feature, the most important characteristics for mathematician is the persistence. It's regardless. I think intelligence is important, but not that as important. So young people have more energy, but the more important thing is to just keep on doing a problem until it is finished. Never give up. That's the most important feature. Some young people probably very smart, very energetic. If they cannot be persistency, it's difficult to do math research.
No question up here?
Do you, when you study the superstring theory, do you have any personal beliefs?
Well, I don't know a lot of the physics aspect of string theory, so I don't know how to answer that question. And there are other physics theories. Well, I never thought of the question very carefully, so I don't know.
Scientists don't believe.
You talked about one sort of specialty of mathematics. Has things got so specialized that, say if you were reading papers in another branch of mathematics, that you would find it very difficult to follow the details and vice versa, work in mathematics application?
This is the problem, because nowadays with many more people studying mathematics and faster developing in mathematics, there are many more branches. So everybody has to be more specialized than they used to. But on the other hand, it is not a good idea to work on a very specific problems. The better way is that we don't distinguish different math branches. Like I don't want to be called a complex geometer, even I study complex geometry. I prefer to be called a differential geometer, or I prefer to be called a mathematician. And so a good piece of math work is always interdisciplinary. So like in our work, it's related to string theory, it's related to topology, related to complex analysis. So that not only it is important, not only it brings a lot of math branches to move forward together, but also it can be appreciated by more people among mathematicians.
Any other questions? One more. Yes.
In the pursuit of a project such as those you described, if the solution coalesces late in the project, how do you know when you're not going to succeed? You should quit.
Yes, let's put it this way. For me, is I'm happy is what I'm very happy to so far everything I persisted to think I eventually was successful, but maybe not in the future. But the other things is, in fact, after thinking of the problem for 1 year or 2 years, it's very difficult to get rid of it. Even at the risk of just losing the grant, at the risk of not being promoted, keep thinking of that. I just think of this, my problem almost every day. So that's, yeah.
I'm wondering, since you grew up in China and now you teach in the
Okay, so the question is comparing to U.S. education system with that in China. So this is a big question. I have a child only 3.5 years old, so I didn't start to think about that question. But I think on the top, so frankly speaking, I don't have much knowledge about that. But I think on the top level of Chinese students and the US students, they are almost similar. They work very, very hard. It's not like Chinese students work very hard in mathematics for a lot of problems, and US students I see in UCI there are a lot of very hard-working students. I work with some of undergraduate students. I know they work as hard as Chinese students.
Okay, so let's thank Professor Lu one more time. I want to thank you all for being here. Your support, just by being here, is already a big boon to our school, and we look forward to your participation in the future. Our next lecture is on May 18th, and it goes almost all the way to the other end of physical sciences, which is bringing climate change solutions to your backyard. So it should be very practical. It'll be presented by Diane Pataki in our Earth System Science Department. Once again, I'd like to emphasize the School of Physical Sciences tries to squeeze value out of every penny, so we'd like to ask you to leave your badges on the table because we'll use them again. We'll recycle the badges. I'd like to thank Nicole Wilson for all the work she did to make this morning possible. And with that, I hope you have a great day, and we'll see you again on May 18th.
Yes.